All right, I am going to be doing some simplifying of radicals, and this is otherwise known as extracting radicals or extracting square roots. So I'm going to show you not necessarily the fastest way to do this, but I am going to show you just one way because, again, I know a lot of times people, when you're doing these, you're asked to simplify, which means you're not just able to hit the square root button on the calculator and type that out and then get an answer. So I'm just going to give you kind of just an easy way, but not necessarily the most efficient way to do this. So when I'm doing this, I want to focus on two numbers that when multiplied get me the number that's under the radical symbol. So this is to get 24. So you can just think of any two numbers that come to mind. And so again, I'm kind of purposely going to do this a different way this time. So I'm going to go with the square root of 12 times the square root of 2. 12 times 2 gets me 24. This is not the most efficient way though. Now, with that, I can look at these two numbers and say, okay, well, am I at a prime situation here? I am a prime with 2, but I'm not a prime with 12. So what I'm going to do is I'm going to break 12 down a little further. And I'm going to say 2 times 6. Okay, now the reason why I'm doing this is because I want to just show you that when you're looking at something like this, it's possible that you might not pick the best option here. So when you see a pair of radicals like this that is exactly the same, you should immediately kind of think about those. Those two are going to cancel the radical out, leaving you with just the number 2. So 2 square root times 2 square root would be 4 square rooted, and 4's square root is 2. So essentially, you see the tip pair, you can take the 2 and just eliminate that radical symbol. You can do that with any set of pairs of identical square roots. Now we look at 6 and then we see, okay, there's only 2 options here. 1 in itself, which isn't going to help me, or 2 and 3. Both of those numbers are not perfect squares. So because those are prime numbers, I can't do anything further with that. And because we've already eliminated a set of square roots of 2, that's not going to help me either. So this would reduce down to 2 root 6. So that's as far as I'm going to be able to go with that. Now I'm going to do this again. I'm going to do this a couple of different random ways. Now normally you could just multiply these 2 square roots and do square root of 5 times the square root of 10 and get square root of 50. But I'm going to show you a different way to do this. 10 can be broken down, obviously 10 in itself, or by 5 and 2. So we're going to do this. Now, again, I'm showing you this for a reason. I have a pair of 5s right here with square root and symbol on them. They are identical, which means the square root symbol wipes away, leaving with just the number 5. Now, root 2 is a prime number, so I can't do anything further with that. And so this would be my simplified answer for this question. Now let's take a look at a couple more. I'm going to do a couple more of the radicals, and then I'll do a couple of rationalizing the denominator in my other videos. And again, if you would like more questions like this, you can find them on my YouTube channel, YouWantAlgebra. Check them all out under my Roots and Exponents playlist. You can also find these on Instagram and my TikTok.